Brothers Mario and Luigi loved to watch the tides at the beach. Their mom, sharing their love for mathematics, taught them how to measure the tides. At 6 a.m., the tides were at their low point and reached a height of 2 feet. At 12 p.m., the tides were at their highest point, 30 inches higher than the low point. Write an equation that models the height of the water where t equals 0 represents 12 o'clock midnight and h of t represents the height of water in inches. I'm going to display this problem for you, and I challenge you to pause this video and try it on your own. What's so cool about these problems is there are infinitely many correct equations that you could write. So I'm going to show you one way you can think about the problem, but understand that you might have the right problem too. And I'll talk about what pieces need to be the same in both of our equations if you get something different. The first thing I like to do in a problem like this is to draw a sketch of the graph. So I'm going to draw a XY axis and figure out what my labels are. So we're given time and we're given the height of the water in inches. So let's go back real quick. It says that t equals 0 represents 12 o'clock midnight. So right here on my x-axis, this is going to represent 0. So I'm going to quick scale these by 2s. So this is 2 o'clock a.m., 4 o'clock, 6, 8, 10, 12. Let's just go a little bit further, 14, 16, 18, 20, 22. Oh, and there's 24 hours in a day. So let's call that 24. And this is going to be our time. The other piece of information we're given is the height, and they want the height in inches. The first data point we're given is that at 6 a.m., it reaches a height of 2 feet. But this problem is asking for it in inches, so I'm going to go ahead right away and I'm going to convert this 2 feet into 24 inches. So I'm not going to use this. The second data point I'm given is that at 12 p.m., that it's 30 inches higher than the low point. So to get this data point, I need to take 30 plus the low point, which is 24. That puts me at 54. So 54 inches. I'm going to go ahead and just plot those points on my axes. Let's call this our low point. So let's say this is about 24 inches. And let's go to our high point here, 54 inches. So 6, 24. And we also have 12, 54. Now, when problems give me a maximum and a minimum point, I like to write a cosine equation. The parent function of cosine looks like this. And if you flip it over, it looks like this. And so that's what I'm going to do here. So I'm going to use an equation that's in the structure. Y equals A times cosine B x minus h. Notice this double set of parentheses plus k. The A represents the amplitude, or the vertical stretch from the midline. B represents the number of cycles in 2 pi. H is your horizontal shift, and K is where the midline is, so that vertical movement of the midline. And recall that the midline is the halfway point between the maximum and the minimum. So what I have to start is I have half of a cosine graph right here. So I want to complete this and have it come all the way down to help me figure out this information. So from 6 to 12, it's minimum to maximum. So I want to come back to the minimum, and that's going to be 6 away from the 12 because this is a distance of 6. So 2, 4, 6. I like to have minimum points, I like to have maximum points, and I like to have the points that fall on the midline. The midline falls halfway between the 24 and 54 inches. So what I'm going to do is I'm just going to draw a dashed line right here to represent the midline. And that's going to be halfway between 24 and 54. Halfway between 54 and 24 is 39 inches. To get our points in the midline, we needed to go halfway in between the maximum and the minimum, This is a distance of 6, so we're gonna go 3 away because that's half. So 6 plus 3 puts me at 9 right here, and I'm gonna come up to the midline. And then I'm gonna go halfway in between these 2 points, which is the 3 away. So 12 plus 3 is 15, and then plot that point on the midline. So what I have right here is 1 cycle of a cosine function. And I'm gonna use that picture to help me get this stuff. So we have y equals A, our amplitude is the distance between the midline and the maximum. I need to take 54 minus 39 to get that distance. That's 15. Now, because this cosine graph is opening down, I'm going to put a negative out in front of it. This is a cosine function. To get the b value, again, b is the number of cycles between 0 and 2 pi. And so to get the b value, you're going to take 2 pi divided by the period length. 1 period goes from 6 to 18. So if I do 18 minus 6, that's 12. And if I simplify this, I get pi over 6. And 12 makes sense for this part because if you can think about it, 12 hours is half of a day, right? So I'm going to go ahead and put pi over 6 for my b value. X is our input, so that's always part of the equation, minus my h value is how far this cycle is shifted over. And it looks like it's shifted over 6 to the right, so I'm going to put a 6 in here. And the k value is where the midline is moved up to, so that's 39. Now, when you paused and tried this on your own, you may have gotten a different equation. Things that should stay the same in the equation are the amplitude, 15, pi over 6, and that vertical shift of the midline. So 15, pi over 6, and 39 should be the same. Your h value should be how far your function is shifted over. So mine, I started at 6. But if you started at this point, maybe you said that was 9, okay? And if you started at 9, maybe you used a sine function because sine starts on the midline, it goes up, down, back under the midline, and then comes back up. Then you would have also gotten rid of that negative. Depending on what function you use, is it facing downwards? Is it facing upwards with respect to the parent graph? That's how you'll decide that, okay? So things that can change are this, the negative sign, whether it's positive or negative, cosine or sine, depending on what type of function you're using, and then that horizontal shift. Everything else should remain the same. Now, I'm going to show 2 extension problems where we can use our equation to help us get the answer. Pause and try this on your own first. To answer this question, I need to recognize that 7:30 a.m. is a time, and time is an input for this function. So this is the equation that we came up with, and so we are going to be replacing this x with that 7:30. In order to put it in here, I can't put the time 7:30, so I'm going to have to change that into a decimal. 30 minutes is half of an hour, so I'm going to input 7.5 in for x. There's 2 ways I can do that. I can copy this, paste it, and put in the 7.5. At 7:30, the height of the water is 28.39 inches. Another thing I could do, because I defined this as a function, is type in f of 7.5. So I get the same answer that way. Now, when you type in your equation, if it doesn't show up right away, notice that the midline for this equation is 39, so you will have to do some adjustment here to be able to see this whole graph. For this problem, we're given the output instead. We're trying to figure out when the water is going to be 4 feet high. But since this problem is defined in inches, we need to take that 4 feet and change it into inches. So I'm going to do that first just by doing 4 times 12. So I know that my output has to be 48 inches. Now the best way to do this using this graphing technology is to first graph the function, which I already have graphed, and then also type y equals your output value 48. And I'm just going to change the color here. This allows us to see all of the times where the wave is exactly 48 inches tall. And this question asks us the first time after midnight. And so if I come here, remember 0 represents midnight, I'm going to come to this graph, click this point, and it looks like my answer there is 1.771. I'm just going to type that here. So it's 1 a.m. and something. So that's not a good time though. So in order to get the time, we're going to take 0.771 and multiply it by 60. That will give us in terms of minutes. So it's at 1:46 a.m. for this problem.